Hello, my name is Jared McClure, and this is my contemporary issue presentation. I will be talking about graphene desalination of water. Right now, it is a process still in the works, but it's an interesting process nonetheless, and I see a lot of potential use in society if they can actually get this research down and implemented. So an introduction on graphene for anybody who doesn't really know. Graphene is a two-dimensional layer or sheet of carbon atoms they first found it when they put a piece of scotch tape to graphite, solid graphite, and they kept separating the tape and eventually got down to a 2D structure of just the graphene, but that's hard to extract, which is another problem of using graphene, but that's for later research. Graphene has notable high electrical and thermal conductivities. It is supposedly theorized to be stronger than steel, and it is a porous open structure because you have the carbon hexagonal structure, which is porous to materials that allows for separations, or at least idea is that things can separate through the carbon rings. So initial research was conducted by a group at MIT who was looking at different ways other than reverse osmosis, which is the current way to take salt water and remove all the salt so that you just have fresh water. This process is called desalination. So currently reverse osmosis is what they are doing to purify water, and it's a good process in the sense that we're able to convert it on like naval ships and stuff at sea, but it is fairly expensive and costs a lot of energy costs to purify the water. So they're looking for graphene, which they think at lower pressures will be able to separate the salt from water. There's also some ideas of separating strands of DNA from each other, but that is a genetic engineering thing. Relevance to society. So graphene. So right now, there's a lot of developing countries, not really the U.S., but I mean, if we had free water too, that'd be nice. So there's a lot of developing countries that are in need of water, and there's an abundance of water. It's just ocean water, and so the question is, how do we take that and make it into something that we can actually drink, and so that water is free, and we don't have to waste our money on water, and we can spend it on other useful things in society. So essentially, the idea is to come up with a system that allows for everybody to have access to free water. So some methods. They were going to compare, they can't actually synthesize graphene in the lab yet because taking the 2D structure into a 3D structure is fairly complicated right now. What they are doing is using computer simulations to compare the fluid flow of water through graphene, and also compare the same flow just with reverse osmosis techniques. They're also conducting this at normal pressures, because normal pressures are inexpensive and all around us at approximately 1 atmosphere, depending on if you're at sea level. But fairly normal pressures to keep the cost down and see how it can operate at an industry level. So the results were less than promising. So I found one graph that shows like fluid flow of graphene, and it shows that there is a peak at which the flow is the highest, but I found other articles that said that when you're comparing the flow of water through graphene, they thought it was initially going to be very quick, but what actually happens is it's like honey, just 100 times slower, And imagine just like graphene just dripping, or water just dripping through the graphene pores. So it's not very promising, and shows to be a higher energy expenditure than reverse osmosis. Also, they found that electron flow was severely limited with graphene. And what are the takeaways from this? So, although reverse osmosis is still going to be the standard for desalination techniques, more research is going to continue into why graphene can't perform like it was expected, and also other properties of graphene that might not be helpful in this case, but could be helpful in cases where you could use graphene in like construction or even genetic stuff if you want to do it at a slow rate, I guess. But yeah, it continues in the research phase, and that is my presentation. Are there any questions?
No.
No questions? Okay, thank you so much.